So today we are talking about chapter 1.3, moving right along. In our learning goal, it's all about properties, okay? So our learning goal today is to use properties of operations to solve problems, okay? Lots of mathematical academic words in that sentence, in that learning goal. And we're going to break it apart and figure out what in the world that means. So it says you can use the properties of operations to help you evaluate numerical expressions more easily. Okay, that you've already learned 3 different properties of addition. The first one is called the commutative property of addition. Let's all say that together. Commutative property of addition. That commutative property of addition says that if you change the order of the addends, or you change the order of the numbers that you're adding, the sum stays the same. Okay, so if you're going to do a math problem and it says 12 plus 7, is that going to equal the same thing as 7 plus 12? Yes. Changing the order of the numbers when you're adding does not change the total. What property says that?
The commutative property of addition.
The next property of addition that you also already know is called the associative property of addition. Let's say that. Associative property of addition. Okay. That one says that if the grouping, how you group the numbers that you're adding, if you change the way you group it, the sum also stays the same. So you'll see in your book right here that 5 plus, in parentheses, 8 plus 14 is the same as if you change the parentheses. If you first do 5 plus 8 and then plus 14. Yes?
Yes.
Okay. What property says that that's true? Perfect. The last property that you also have already learned is called the identity property of addition. The what?
Identity property of addition.
Okay, and that says when you add 0 to any number, the number stays the same. If I do 245 plus 0 equals?
245.
Is that an easy math problem for you to do?
Yes.
How come it's so easy for you to do in your head? What property makes it so easy for you to do in your head? Adam?
Because you just have to add nothing to the number.
So what's that property called?
The identity property. But can I?
There are also properties of multiplication. Okay, the same properties that work for addition also work for multiplication. So let's take a look. The commutative property of multiplication. It says that if I multiply if I'm multiplying 2 numbers and I change the order of the factors, the product stays the same. So 4 times 9 is the same as 9 times 4. Right? Same as in addition. Then there's the associative property, and we know that that deals with grouping. So we know that if the grouping of the factor changes, the product still stays the same. So if I do 11 times, and then in a group, 3 times 6, that's the same as if I first group 11 times 3, and then times 6, right? If I first do this table group plus Rashika versus that group plus Joseph, it's the same, right? In the end, the result is the same. Finally, the identity property of multiplication, is this exactly the same or is it different, a little bit different than addition? Huh, what's different about it? Siddharth?
Well, one, you're multiplying by 1, and you're getting the same number, and I also have another property.
We're gonna hold on to that. For the identity property of addition, it says any number plus what will equal itself?
1.
If I do 1 plus 1, is that the identity property of addition? It's 1 plus 0 equals 1. But if it's the identity property of multiplication, do I multiply it by 0?
No.
Is 1 times 0, does the identity stay the same?
No.
I have to multiply by what? 1. So the identity property of multiplication says that the product of any number and 1 is that number. Okay, so this table right here shows the number of bones in several parts of the human body. Okay, it shows you how many bones you have in your ankle, how many bones you have in your ribs, your skull, and your spine. What is the total number of bones in the ribs, the skull, and the spine? Okay, so to find the sum of these numbers, we can use the commutative property and the associative properties of addition. Okay? So, how many bones are there in the ribs? Jason. Look at the chart. How many bones are there in your ribs? 24. So that's why they wrote 24 right here. plus, okay, they want to know how many bones are in your ribs, your skull, and your spine. So we know there's 24 in your ribs. How many are there in the skull? Karan? 28, so that's why they wrote plus 28. And then how many bones are there in your spine, Joseph? 26. So that's why right here they wrote 24 plus 28 plus 26. Now, is that really easy to do in your head in that order? 24 plus 28 plus 26? If I rearrange the order, would it be easier? Okay, so they suggest maybe doing 28 plus blank plus 26. What goes in the blank there? 24. When I'm rearranging the order of the factors, what property am I using? What says I can rearrange the order of the addends? Arushi? The commutative. Good, write that in. That's why I know it's okay to rearrange the order of the addends. Now, should I add 28 plus 24? Is that easy to add in my head? Or is it easier to add 24 and 26 first? Okay, so that's why they've added the parentheses. They said you should add first 24 plus 26. What property makes it okay for me to change the grouping when I'm adding numbers? Neha? Associative. Good. Oh, I spelled it wrong, so don't do it like me. Oh.
You have good research.
Thank you. Associative property. Okay? Why is it easier to group 24 and 26 before you add the 28? Why did we choose to do that? Nathan?
Because 6 plus 4 is 10, and 10 is easier for
Yeah, we can make 10 really easily. So what's 24 plus 26 in your head? Daniel?
It's 50.
50. And now can we really easily do 50 plus 28?
Yeah.
So how many bones are in your ribs, skull, and spine? Liam?
78.
78. Terrific. A new property we are going to learn today is called the distributive property. Okay? The distributive property you may already know, which is terrific, and if you don't, either way, we're going to review it. The distributive property says that multiplying a sum, so if you're adding two numbers and you're going to multiply that sum by a number, it's the same as multiplying each addend by the number and then adding the products. Okay, so let's take a closer look over here. We have 5 times the sum of 7 plus 9. I could do the sum first. What's 7 plus 9? 16. So I could do 5 times 16. Or, that's not super easy for me to do in my head, so I could use the distributive property, and I could distribute the 5 to each of the addends. I could do 5 plus 7, and then plus 5 times 9. Is that easier? Yeah. So what's 5 times 7? We know that math fact in our head. And what's 5 times 9?
45.
What's 35 plus 45? 80. So let's see if that is truly the same. So if I did 5 times 7 plus 9. What did we say 7 plus 9 was?
16.
Okay, what's 5 times 16?
80.
So do the two answers equal the same? Yeah, they're the same. Which one's easier? Yeah, okay. Let's look at this. It's also in your book. It says the distributive property can also be used with multiplication and subtraction. So here, down here, we have 2 times the difference of 10 minus 8. Now we could do that first, and we know 10 minus 8 is 2, and we could do 2 times 2, or we could do 2 times 10 minus 2 times 8. We could distribute the multiplying to both of the numbers inside the parentheses. Okay?